The oxygen system supplies oxygen to the crew members and passengers in case of cabin depressurization. The oxygen system consists of a gaseous system and a chemical system. The gaseous system contains the crew oxygen system and the portable system. The chemical system consists of the passenger oxygen system. The flight crew oxygen system provides the pilot, co-pilot, and an observer on the flight deck with a source of supplemental oxygen, free from effect of smoke or harmful gases. The masks operate independently and contain pressure demand regulators. For example, in the event of a cabin decompression, the system will provide sufficient oxygen to the crew, including a calculated descent from 41,000 feet to 10,000 feet in 22 minutes, and continuous supply with the remaining available oxygen up to a maximum of 2 hours. The system consists of one oxygen cylinder installed in the right-hand central fuselage underfloor area, providing oxygen to 3 sweep-on full-face oxygen masks, which are in stowage boxes in the cockpit. A pressure transducer continuously senses system pressure for display on the ICAS system. A mechanical pressure gauge accessible from the outside of the aircraft monitors system oxygen content. The passenger oxygen subsystem is composed of oxygen dispensing units provided along the passenger cabin in the PSUs, in both lavatories, at each flight attendant station, and in the forward galley area. The chemical oxygen dispensing units supply the occupants with supplemental oxygen for 12 minutes during an emergency descent in the event of cabin decompression. The Secondary Power Distribution Assembly 1, SPDA-1, provides control of the system if the passenger oxygen panel switch is set to the automatic mode. The SPDA receives inputs from an altimetric switch and the cockpit control switch and provides output to the dispensing unit latches and the cockpit indicator light. Portable oxygen equipment is installed in the cabin for cabin crew use. 2 portable oxygen cylinders are installed for first aid purposes and may also be used to assist passengers in case of sudden decompression. The portable cylinders are located near each cabin attendant station. Protective breathing equipment, PBE, units are used during emergencies by aircraft crew members for respiratory and visual protection against the effects of smoke and harmful gases while combating fire in the aircraft, or when there is smoke in the cabin. PBEs are stored near each cabin attendant station and in the cockpit. The oxygen system status indication has 3 parts: the central maintenance computer indications, the engine indicating and crew alerting system indications, and the status page. In case of system failures, or if built-in test fails, maintenance personnel use the CMC indications to determine how to fix the aircraft. The flight crew uses the ICAS indications for flight safety, and the status page for an overview of crew oxygen system status. The fixed crew oxygen system has 3 subsystems: the supply subsystem, the distribution subsystem, and the dispensing equipment subsystem. The supply subsystem includes the following components: oxygen cylinder with regulator, oxygen discharge line and indicator, fill port, oxygen pressure transducer, temperature sensor and pressure gauge, high pressure hoses and exhaust orifice and flap valve. The distribution subsystem includes low pressure hoses and lines and crew mask stowage boxes. The dispensing subsystem includes full face masks and regulators. The oxygen cylinder is installed in an insulated compartment in the right-hand central fuselage underfloor area, adjacent to the cargo compartment. The oxygen compartment is completely sealed in order to prevent oxygen leakage to adjacent areas. A composite cover separates the oxygen system from the cargo compartment. A flap valve installed on this cover controls the air inlet to the oxygen compartment, so that airflow is only allowed from pressurized areas into the oxygen compartment, reducing oxygen concentration. In case of a leak, the oxygen will vent out from the oxygen compartment through the overboard orifice, and an internally installed noise suppressor will reduce the noise caused by the leak. The oxygen cylinder is a 50 cubic foot, or optionally, a 77 cubic foot aluminum shell with Kevlar fiber epoxy-wrapped composite cylinder and regulator. The cylinder assembly is protected from overpressure by the regulator-mounted high-pressure rupture metallic disc, which is designed to rupture when cylinder pressure reaches 2700 psi at 21 degrees Celsius, 70 Fahrenheit. The rupture pressure decreases with increasing temperature to about 2450 psi at 71 degrees Celsius, 160 Fahrenheit. The regulator is a single-stage on-off unit capable of delivering a minimum flow rate of 300 liters per minute to the distribution system at 70 psi. The regulator is lock-wired in the on position at all times when installed in the aircraft, and should be turned off when the cylinder is removed from the aircraft for servicing. For maintenance, a high-pressure transducer and a mechanical pressure gauge are provided at the remote fill port. An overboard discharge line and indicator are mounted on the aircraft skin. Cylinder pressure is also provided to the Engine Indication and Crew Alerting System, ICAS. The pressure transducer is used to sense cylinder pressure, and then convert it to an electrical signal that is sent via the AMS controller to a display in the cockpit. The corrected oxygen pressure is calculated using the temperature of the cylinder along with the pressure reading from the transducer. If the oxygen temperature sensor is invalid, then the flight deck zone temperature is used. If the temperature sensor and the flight deck zone temperature sensors are invalid, the oxygen temperature is set to the default of 51 degrees Celsius, 125 degrees Fahrenheit. The crew oxygen system does not depend on the AMS channels to operate. Rather, it remains fully operational under all AMS failure conditions. This panel-mounted fill valve is used for remote charging of high-pressure aircraft oxygen cylinders using charging adapters. Each valve has a check valve, flow control resistor, and integral filter. Click on the charging button and follow the procedure as shown. Remember, this animation is for training only. For updates and detailed procedures, always refer to the Aircraft Maintenance Manual. Open access door 132AR. Check the overboard discharge indicator before you fill the oxygen cylinder to be sure that the safety fitting did not discharge. Remove the cap, connect the hose, and make sure that there is no leak. Open the valve and fill the system slowly at a maximum rate of 300 psi per minute. This prevents overheating of the system. Monitor the pressure and at the correct pressure close the valve. Allow the temperature to stabilize. Check the pressure and remove the oxygen adapter. Install the protective cap and close the access door. The Sweep-On full-face stowage box is designed for optimum safety and ease of use. The stowage box connects the masks directly into the aircraft's cockpit communications and oxygen system. The container doors contain integral spring-loaded hinges so that they can be fully opened or fully closed. They also include a test reset button with a flow indication blinker used for mask regulator testing without removal from the container. The flow indicator responds to oxygen flow when the test reset button is pressed or when the mask is used. The indicator shows a bright color contrast upon sensing flow through the supply line. The container also has an optional microphone on-off switch, which allows the mask to be stowed in a non-pressurized state with the microphone off. When the doors are opened or the test reset button is pressed, the regulator is pressurized and the microphone is activated. Both the regulator and the microphone remain functional after the doors are closed and until the test reset button is reset. The Sweep-On Full-Face Oxygen Mask with Pneumatic Harness contains a mask-mounted automatic diluter demand regulator. The regulator has a knob mode control with 3 positions: normal, 100%, and emergency. The mask is normally stowed with the control knob set to 100%. The face seal can be easily removed for replacement or cleaning. The face seal includes integral purge valve assemblies. These purge valves allow oxygen to enter the face seal, purging smoke and fumes. The purge valves automatically open when the regulator is in the emergency mode. The mask comes with an optional automatic microphone cutoff, which deactivates the user's microphone during inhalation, providing more understandable audio transmissions. Using only one hand, the mask can be donned and functioning in less than 5 seconds. When the inflation button on the side of the regulator is pressed, the harness fully inflates, allowing it to be placed over the user's head. Releasing the button deflates the harness to the point that the mask is held comfortably in place. Since the flight crew oxygen system should always be ready, an oxygen pressure indication is provided on the status page to show the oxygen cylinder pressure. Each crew member must verify the operation of his mask during the pre-flight check or during flight crew change. During normal operation, the masks are stowed and the regulator knob is set to the 100% position. This setting will provide 100% oxygen to the user upon inhalation, regardless of cabin altitude. In the norm position, the regulator provides automatic oxygen dilution. At lower cabin altitudes, air is allowed to enter the regulator and mix with the oxygen. As the cabin altitude increases, the percentage of ambient air entering the regulator is reduced until a preset point where 100% oxygen is delivered to the user. The emergency control setting also provides 100% oxygen regardless of cabin altitude. In addition, oxygen is supplied at a slight positive pressure, which purges smoke and toxic fumes from the face seal and maintains protection. If the system fails, the caution message, "Crew oxygen low pressure," will be displayed on the ICUS. This caution message indicates that 50 cubic feet pressure has fallen below 976 psi, or that the optional 77 cubic foot tank pressure has fallen below 704 psi, or that the pressure sensor has failed. The CAS message, "Observer oxygen low pressure," indicates that 50 cubic foot pressure has fallen below 1365 psi, or that the optional 77 cubic foot tank pressure has fallen below 956 psi. The crew is then required to descend to 10,000 feet as soon as possible. Additionally, the central maintenance computer will provide messages in case of system malfunction, such as oxygen cylinder ambient temp sensor fault or oxygen cylinder pressure sensor fault. The passenger oxygen subsystem is composed of oxygen dispensing units provided along the passenger cabin in the PSUs, in both lavatories, at each flight attendant station, and in the forward galley area. The chemical oxygen dispensing units supply the occupants with supplemental oxygen for 12 minutes during an emergency descent in the event of cabin decompression. The Secondary Power Distribution Assembly 1, SPDA-1, provides control of the system if the passenger oxygen panel switch is set to the automatic mode. The SPDA-1 commands energization of DC bus 1 and 2, which then energizes the harnesses to which the latches are connected, and illuminates the cockpit indicator light. The oxygen dispensing units are attached to the PSU assemblies. There is one PSU assembly and dispensing unit for each seat position. The unit consists of 2 or 3 oxygen masks, determined by the location of the unit. The components are housed in an aluminum container with 2 hinged doors to retain the masks. The unit also includes one 12-minute chemical generator covered by a thermal insulation blanket to protect against heat during the chemical reaction, and by a heat shield for passenger safety on the cabin side of the generator. The oxygen container has 2 latches, an electric door latch and a mechanical test latch for testing mask deployment on the aircraft. The oxygen dispensing unit doors will deploy automatically during normal operation, or can be opened directly from the cabin using the manual release feature. The mechanical test latch permits the door opening to be periodically tested without deployment of the masks. The test latch allows the doors to open approximately 5 degrees from the normal closed position. The chemical generator is a stainless cylinder with a solid chemical core that produces oxygen when the chemical reaction is initiated. Each generator has an initiating device to start the reaction. The device consists of a spring-actuated striker and a percussion cap. The striker is separated from the cap by a pin inserted into the shaft. The pin is attached to the mask. When the mask is pulled and put on the face, the pin separates from the shaft and the striker contacts the percussion cap, initiating the reaction. During the chemical reaction to produce oxygen, the generator temperature may rise up to 274 degrees Celsius, 525 Fahrenheit. The generated oxygen passes through a filter to assure clean, contaminant-free supply. When the generator has been used, a colored indicator fitted on the generator changes from orange to black. A pressure relief device vents the cylinder case to prevent overpressure. The altitude switch used in the passenger oxygen system is located in the forward E-bay near the CPCS controller. The altitude switch closes at 13,500 to 14,000 feet on increasing cabin altitude, and resets before 10,000 feet on decreasing cabin altitude. When the switch measures the increasing cabin altitude of 13,500 to 14,000 feet, a signal sent to the forward SPDA automatically deploys the passenger oxygen masks. The constant flow passenger masks operate by combining the required supplemental oxygen for a scheduled altitude with ambient air to provide the required oxygen level to the users. The mask consists of a one-size-fits-all molded bright yellow silicone rubber facepiece. Since the mask does not cover the entire face, the wearer is easily identifiable in an emergency. A single, easily adjusted headband attached to the facepiece valve plate secures the mask to the face. A vinyl reservoir bag imprinted with pictorial quick donning instructions is attached to the facepiece at the plastic valve. The oxygen flows through a vinyl tube attached to the reservoir bag. The other end of the tube is connected to the chemical generator outlet and to an inline flow indicator, and then into the reservoir bag before entering the mask. The passenger oxygen system flight deck interface is located on the passenger oxygen control panel. The switch controls automatic or manual operation of the system, and an annunciator indicates when the masks are deployed. The selector switch has 3 positions: off, auto, and override. To avoid human error when moving the switch out of the auto position, it has to be pulled out and then turned to either off or override position. In auto mode, the system is controlled by the SPDA-1, which senses cabin altitude from the altimetric switch and automatically deploys the oxygen masks when the cabin altitude exceeds 14,000 feet. Selecting override mode activates the system at any time, independent of cabin altitude. In off mode, the system is turned off and does not function automatically or manually. This feature is required for landings at airports higher than 14,000 feet to avoid the oxygen masks dropping out. The no smoking and fasten seatbelt indicators on the PSUs will illuminate automatically whenever the masks are deployed. In normal operation, all the doors of the oxygen dispensing units are latched closed and the control panel selector switch is set to the auto mode. In case of sudden cabin decompression, the altitude switch will sense the cabin altitude increase. And at cabin altitude 14,000 feet, or at the discretion of the crew, a 28-volt DC electrical signal is provided to the dispensing unit latches via the SPDA. The dispensing unit latches will be energized for 6 seconds, allowing the doors to open and deploy the masks. All masks are thus automatically deployed to the passengers. When the passenger pulls the mask to the face and places the mask over the mouth, the chemical reaction begins, and the oxygen flows into the mask. During abnormal operation, when the auto mode has failed to deploy the oxygen masks, an ICUS caution message, PAX, oxygen not deployed, is presented to the flight crew. Following the abnormal emergency procedures, the flight crew selects the passenger oxygen selector knob to override position. The mask deployment will be confirmed when an indicator light, on, illuminates on the control panel, and the caution message, PAX oxygen not deployed, disappears. There are 3 portable oxygen cylinders installed in the EMBRAER E190 passenger cabin near each cabin attendant station. 2 cylinders in the forward cabin are located in an enclosed and latched compartment, while the cylinder in the aft cabin is located on the forward face of the left-hand divider panel behind the last passenger seat. The cylinders are intended to be used by the flight attendants for passenger first aid therapeutic treatment purposes, or to assist passengers in case of sudden cabin decompression. The protective breathing equipment, PBE, is for emergency use by the crew members or flight attendants for respiratory and visual protection against the effects of smoke and harmful gases while combating fires in the aircraft or during a cabin smoke condition. There is 1 PBE installed in the cockpit and 3 in the passenger cabin, 1 in the forward section of the cabin, and 2 in the aft section within 3 feet of the fire extinguishers. Each portable oxygen unit includes a 312-liter, 11 cubic feet oxygen cylinder, an on-off pressure reducer, pressure gauge, charging valve, high-pressure safety relief valve, 2 oxygen outlets, carrying strap, and 2 constant flow therapeutic masks. The cylinder pressure for dispatch is 1200 psi, a pressure calculated for the maximum utilization period of 30 minutes. The regulator on the cylinder has a high-pressure frangible safety disc with a rupture range of 2700 to 3000 psi. To obtain the specified flow volume, the mask is connected to one of the cylinder outlets and the handle is turned to the full on position. The operating and charging instructions are attached to each cylinder. The PBE is stowed inside a vacuum-sealed aluminized bag and is attached to the bottom side of a rigid, flat, orange box. The cover box has a green good condition indicator and handle. The box also features an operating instruction pictogram, an identification plate showing the manufacture date, and a fastener which locks the cover on the container with a lead seal. If a leak occurs during stowage, oxygen will escape from its ring-shaped container and fill the vacuum-sealed bag. The indicator will permanently turn from green to red, indicating that the hood might not meet its minimum duration of 15 minutes protection time. When the smoke hood is needed, proceed as follows. Open the box by pushing a spring lock and pulling the box cover upwards. Extracting the hood automatically tears the containing aluminized bag and thus allows a direct presentation of the hood. The ring-shaped gas container, which can be deployed by a brisk downward movement, provides an easy way of handling the hood. To don the hood, open the neck collar seal wide by placing your thumbs in front of the red pointers. This is particularly important if the user wears glasses. If dense smoke prevents visibility, the phonic membrane and visor provides a way of properly orienting the hood. The hood is installed by a simple hood threading on the head. Once the hood is on, operation starts automatically. When oxygen flow noise can no longer be heard, the oxygen supply is finished.